All right. So let's get started. Looks like you got lots of good questions for us today. So let's try to get through them. So angular velocity, what formula do you have for angular velocity?
All
right. Go ahead.
It's the angular velocity is it's the circumference times, I forgot.
Do you wanna look in your notes and tell me what that is?
Yeah, I have it in my notes.
Do you remember what variable they use?
It's omega equals theta over t. I got omega equals 30 theta over t.
Omega.
Yeah, omega.
What letter does omega look like?
W.
Yeah, okay. W equals theta over t.
Yep.
Okay. So this is the change in angular rotation, and this is over time, right? Theta. I'm thinking it's I'm trying to look up for myself. Do you not use theta equals s over t or s over r?
Right now.
Oh, because s equals theta times r. You remember that if theta is in radians?
Yeah.
I'm just writing out all the different formulas we might need. So this is the arc length. Okay.
Yeah.
So this is the theta is the change in angular rotation, right? Just putting all those here so that we can see which ones we need to use. All right, so it says the satellite circles the Earth every 3 hours if the radius of the orbit is this much. Find the linear velocity. Well, what's linear velocity? Oh, this is angular velocity. Now they want linear velocity.
It's the angular velocity times the circumference.
Right, so the angular velocity, what do we, or linear velocity, what do we use for linear velocity? V?
Oh, yeah.
V equals the angular velocity times, what is the, I'm sorry, I'm just trying to remember what the formula is for linear velocity. Tell me what that, do you have that in your notes too?
It's, let me see. It's V equals S over T, where S is arc length.
Okay. Yeah. Okay, yeah. So V equals RW is what I was looking for, but you don't use that. But since W is theta over, so see how we got all these different formulas here? You can kind of combine them all together. So V equals S over T is another one. And remember, S is R times theta. So you could do R times theta over T. And W is theta over T. So you could have also said that right there. You see how all those things kind of mix together? So it just kind of depends on what you're given to know what you're going to use, which of these formulas you're going to use. Okay. And then circumference is another thing that you might use, because sometimes they say rotations or revolutions per minute. And so you need to use circumference to determine, you know, the linear to convert to linear. Does that make sense?
Yeah.
Okay, so let's look at the problem now that we have all our formulas. A satellite circles the Earth once every 3 hours. So if the radius is that much, find the linear velocity of the satellite in kilometers per hour. Okay, so we want the linear velocity. So we're trying to figure out what this, so the radius is that much. So what is the circumference that it's going to travel? It's going to be 2 pi r, right? You follow?
Yeah.
So the circumference is 16,000 pi. That's the circumference. And it says the satellite circles the Earth once every 3 hours. So it's going to travel this far in 3 hours. Make sense?
Mhm.
So the velocity is going to equal that's the distance that it traveled over 3 hours. So this is that many kilometers per hour.
All right. Yeah.
Does that make sense?
Yes.
So we wrote all those formulas out, but then we just kind of did it with logic more than anything. So we
Right, yeah,
did,
that
yeah,
works.
we used this one. We used S divided by T because they didn't give us angular, they didn't tell us anything about angular velocity. So again, this was probably unnecessary, but these are all the formulas that we may need to use with depending on what your next questions are about. Okay, good.
Mhm.
All right, next, here we go. This is what I was looking at for those formulas. A gear with radius 8 centimeters turns at 60 revolutions per minute. So RPM means revolutions per minute. Find the angular velocity of gear B with radius 12 in revolutions per minute.
Mhm.
So the idea is that the linear velocities are going to be the same. That's kind of the main concept. The linear velocity is equal to the linear velocity. Does that make sense?
Mhm.
So we're gonna find the linear velocity of this first gear. Let's find that linear velocity, I'll say, of A. The linear velocity of A is going to be equal to the linear velocity of B. So help me find the linear velocity of A. What would I do?
Linear velocity of A is so if we're finding the
So
linear velocity of it, it would have to be the circumference of that. So the circumference
good,
would be 16 pi.
good. So look what I'm doing over here. You're right. See how I'm writing 60 revolutions per minute? And I want to convert that to centimeters per minute.
Mhm.
Does that make sense?
Yeah.
So 1 revolution, I'm putting that in the bottom so that they cancel out, is how many centimeters? And that's what you're doing right now. The
Mhm.
circumference is what?
The circumference is
I think you just said
16,
it, 16,
16 pi.
16
Yeah.
pi. Good. So 16 pi centimeters, right?
Mhm.
So now I have centimeters per minute. So this is my linear velocity.
Mhm.
It's going to be 16 times 60 pi. So 16 times 60, 960 pi. centimeters per minute. Okay. Now that's the same as the velocity, the linear velocity of B. The linear velocity is going to be the same, right? So the linear velocity of B is 960 pi centimeters per 1 minute. But I want to convert this back to angular velocity for this gear now. So what do I do to convert that back to angular velocity? Remember, that's centimeters per minute, but I want revolutions per minute. So what do I have to come up with? To come up with the conversion factor that has what in the bottom? You see how I put revolutions in the bottom so that it could cancel out?
Mm-hmm.
Now I want
Now you can
revolutions
put centimeters on the bottom.
Very good. I want revolution. One revolution is equal to how many centimeters for that other gear? So this was 16 pi. This is going to be, what's one revolution? What's the circumference, in other words?
Circumference is 24 pi.
Perfect. It's 2 pi r, so 24 pi. And now simplify. So I have revolutions per minute. My units are all cleaned up. The pi's cancel out. Does 960 go into, or does 24 go into 960? I hope so. Hey, how about that? It's 40. It's exactly 40. Okay.
Mm-hmm.
That makes sense how we did that?
Yeah.
There may be another way to do that, a different kind of formula, but that's the way that I think helps you understand what's going on the best. You don't have to memorize too many formulas for that one. All right, next page.
Mm-hmm.
Find the values of the 6 trig functions if the tangent of theta equals 3/2 and the sine is less than 0. Well, the tangent of theta equals 3/4 means that, and the sine being negative means that the cosine must be negative as well, right? The tangent is a positive either in the first quadrant or in the fourth quadrant. Does that make sense?
Yeah.
Okay. So this must mean that we have an angle here. There's our theta. Well, our theta is this whole thing right here, right? And 3/4, that means that it's really negative 3/4. So you're opposite and you're adjacent, right? So your opposite is this. So -3 is here and -4 is your adjacent right here. And of course, it's a 3, 4, 5 triangle, which is convenient. So what's my sine going to be?
Sine is going to be -3/5.
Good. -3/5. And your cosecant is just the what?
The opposite. So it's
The reciprocal. Good.
reciprocal.
What's your cosine going to be?
Cosine is -4/5. Oh.
All right. Can you see me now? Can you hear me now?
Yeah. Yeah.
Okay. Am I still streaming? Yes, I am. Good. Okay.
Yeah.
Sorry about that. I have to remember to turn on do not disturb on my iPad. Okay. So what was the cosine?
The cosine is -4 over 5.
Perfect. And what's the reciprocal of cosine? What's that function called?
Yeah. That's
Secant.
secant. Yeah.
Good. And the tangent they already told us was 3/4. So what's the cotangent?
4/3.
Perfect. There you go. All right. It says give the exact values of the tangent of that and the tangent of this. Well, that you can use your unit circle, right? So we're thinking, let me do this in red here. We're thinking of our unit circle. The tangent of 60, here's 60 right here. Remember that point right there was 1/2 comma √3 over 2. So the tangent of 60 is going to be the opposite. It's going to be the sine over the cosine. So it's the √3 over 2 times 2, which is √3, right?
Yeah.
Your tangent is your y over x. So the tangent is square root of 3, and 150 is 30 degrees less than 180. So that's this one. So it's the flip. It's the √3 over 2, but that's going to be negative because it's in the second quadrant. Got it? With me?
Yeah.
So the tangent of that is just going to be the reciprocal of that, but negative. So it's going to be -1 over √3, which equals -√3 over 3. That's your tangent. You understand how I came up with that?
Mhm.
All right.
Yeah.
Let's do this next one in blue. If the cosine equals 0.3, find the cosine of theta plus pi. Well, to do this, let's think about what a cosine, if you add pi to an angle, let's just look at this angle right here since we have it written. This angle is 60 degrees. And so the cosine of that is this right here. It's 1/2. But if I go pi away from it, I'm going to be right here. And what, you see how that's that same, it's going to be that same angle essentially, except the sine is going to be, because I'm down, because I went pi degrees, it's going to be a negative. It's going to be the opposite of that. Does it make sense? So for this, all you really have to do is say -0.3. You understand why?
Yeah.
So
But
that's
then
true of this as well. Look at this one. Here's the
yeah.
cosine of this angle, 150. If you go pi away from it, you're going to be right here.
Yeah.
And now it's that same angle. It's that same, why am I having a hard time thinking of that word? Reference angle. It's the same reference angle of 30. So these numbers are going to be the same, but now it's going to be pi away. So now that's going to be a positive, not a negative. So here's one of the properties that I'm getting at. The cosine of theta plus pi is just equal to the negative cosine of theta. That's a formula on the trig property sheets that you'll see.
Mhm.
But I demonstrated that for you by looking at this example here, that unit circle.
Mhm.
Okay.
Yeah.
For this last one here, this looks like fun. Find the exact value of the sum of all of those things. I feel like there's a trig property that says that it's just equal to zero. I think it's just zero. Let me think about why I know that. Well, the sine of, okay, so here's how I'm going to think about this problem. There's probably a property for it, but let's look at just the sine. Let's look at your sine function.
Mhm.
Okay. It goes from 1 to -1, and it goes, here's pi over 2, here's pi, here's 3 pi over 2, and here's 2 pi. Okay. So it goes like this. Your sine function starts here. It goes through the origin here and here. It goes up here and it goes down here. You understand? Are you with me?
Yeah.
So I'm trying to draw this in, give you a visual of what's going on. So if I've got sine of 1, that's this right here.
Yeah.
That and this, these two things are going to cancel each other out. Because this is a positive value and that's the negative value associated with it. So every one of the values here, every one of those, now we're just doing, we're doing 1 degree, 2 degrees, right? So we're actually just taking dots along the way. We're not taking every single one of them, but we're taking this one and 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 this one, this one and this one and this one, like that. We're taking a discrete number of points. We're taking 100, up to that point, there's 180 of those, and then we're taking another 180 points between 181 and 359, and every one of the points here is going to cancel out one of the points here. So this just is going to equal 0. Now there's another way I could probably prove that if I had like a, yeah, I think there is another way I could prove that using this property, right? Maybe this one right here, because I'm just adding pi to it, or 180 degrees. If I add 180, I'm going to get the negative of it. Yeah. So that's essentially what I'm saying. This point right here, add 180, you're going to get the negative of it because the sine is like the cosine. I believe the sine of theta plus pi is equal to negative sine of theta. So they're going to cancel each other out. So that's just going to equal 0. Got it?
Yeah.
Can I move on from that one? Or do you need more explanation for it?
Oh, no, I think I get it.
So that equals 0. All right. Here we go, fun stuff. Let's talk about graphing. This says graph 2 periods of the following equation, state all that stuff. All right, so the first thing that I would like to point out is what you want to do is anytime you have something in here, factor it out. That's how I suggest that you write these things. Some people do it differently, but I just really feel like that's the best way to do it. So if I factored out, this really equals -3 sine of 2 times x plus pi over 4. Understand how I did that? Plus 2. Do you get how I did that? And the reason I prefer to do that is because I'll show you over here to the right. Here's my formula. A sine B, I'll write capitals. I don't know if your teacher does this or not, but a lot of times you write capitals. A sine B of x minus C plus D. Okay. This is your amplitude. This is your period equals 2 pi over that. This is your phase shift. And this is your vertical shift. Okay. So I can see everything that I need to see right here. I can see my amplitude is -3. I don't know if they want you to write the -3 or just 3, but it's basically 3, but it's flipped. So they might want you to say the amplitude is 3. I'm not sure. You'll have to find out what your teacher wants, but it's also flipped over the x-axis. Okay.
Yeah.
My period is pi. Do you understand why?
Yeah.
My phase shift is left pi over 4. See what I'm doing? I'm just looking right there. So because it's a plus here, I'm actually shifting it left pi over 4. And my vertical shift is 2 up 2. Okay. My range is then going to be, since the amplitude was -3, but I shifted it up 2, my range is basically, so here's what I do now. I don't know if I like this graph paper. Did this come with the problem? It did. That's not enough paper. That's not enough points for me. So let me go like this. Let me insert a piece of paper that's a little bit better. Okay. So what I've got is my axis is right here, my x-axis and my y-axis. Make that a little thicker. Okay, and I've got a, I'm shifting it up 2. So my axis of, let's see, what do I call it? My midline, is that what they say? What do they, have they used a word like that, midline, for you? Have they talked about that yet?
For what?
Do they talk about midline?
No, we have not talked about that yet.
Okay, I think that's the best word I've heard. That's my midline. Because it's all shifted, it was all shifted up 2. And then the amplitude is 3, which means the height, the top of it is going to go up to here. So 3 up from the midline, and 3 down from the midline is going to be here. Okay. See that? See how I did that?
Yeah.
Okay. And now the period is pi, but I shifted it. So I'm going to do these in blue. So I did the horizontal lines. My graph is going to fit in here somewhere. It's going to be inside of these 3 lines, right?
Yeah.
Now I got to figure out where I'm putting them. So I'm going to do this in blue. It was shifted pi over 4 to the left. So let's go, I don't actually like this graph a ton because it's got 5, 1, 2, 3. I would prefer that there was just 4. Let's see how I can. I really want, this graph paper isn't the best graph paper. Let's see if I can find some better graph paper to use. Let me find another piece of graph paper. See if they've got some that don't have. I wonder if I can type in Trig graph paper and it'll give me something. Let's try that. Hold on. You'd think that they would have some nice, simple graph paper, wouldn't you? All right, let's see if we can use theirs. Let's see if they're, after all, maybe theirs is better. Okay, let's delete this. And let's delete this. Let's try to use theirs. I just wish they didn't put the axis or the X and Y axis on there, because that kind of limits where I can draw my graphs. So let's see, it's going up to, so I'll do it like this. Here's what I'll do. I got a great idea. I'm going to call this line Y equals 2 because it went up 2. Okay. Does that make sense? So here's my actual Y axis right there. You following me?
Mm-hmm.
So my dotted line is right here. Y equals 2. Let me see if I can make that dotted. I know I'm pulling out all the stops today. You following?
Yeah.
What I'm doing? So there's my
Yeah.
midline. Of Y equals 2. There's my midline. And now I'm going to use the top and bottom. I'm going to go up 3 from there. And I'm going to go down 3 from there. Okay.
Yeah.
And now I'm going to, my phase shift is going to be left pi over 4. So let's call this pi over 4. Do this in blue. So here's pi over 4. Negative pi over 4, I should say. There's negative pi over 4. So here's the trick. If you want to know the interval lengths, look down at the bottom. The interval lengths are going to equal whatever your period is divided by 4. So my interval lengths are, my period is pi divided by 4. So that's nice. There's always 4 intervals on a trig graph, right? You remember what I had originally showed you? It was right here, yeah. Here are my 4 intervals. 1, 2, 3, 4. You see that? So your basic sine graph is period of 2 pi, and divide that by 4 and you get pi over 2. So you label these. If I'm starting at 0, you label them pi over 2, add another pi over 2, add another pi over 2, add another pi over 2. Okay. So when you're doing, this is the hardest part of graphing sine and cosine functions, is labeling your intervals on the x-axis. So your interval lengths, you find your interval lengths by using this little formula. And then, so in our case, the period is pi, and divided by 4 would be pi over 4. And then to find out what your intervals are, here's what you do. You start with your phase shift. Your first interval is your phase shift. Your second interval is your phase shift plus the interval length. I'm calling that IL for interval length. Your third one, you add another interval length, and your fourth one, you add another interval length. That's how you find your 4 points. Got it? You follow what I'm saying here?
Yeah.
So this is easy because our interval lengths are pi over 4 and they're having us start at pi over 4. So it's the first one is going to be there. The second one is going to be at 0. The third one is going to be at pi over 4. And the fourth one's going to be at pi over 2. Got it?
Yes.
And so these are my intervals. If I put like dotted lines here, now let's think about what the sine function does. The sine function normally starts in the middle, right?
Yes.
And it ends in the middle. I feel like I missed an interval. What did I miss? I missed one, didn't I? Sorry, hold on. I don't have enough. Oh, sorry. Yeah, there's one more. And the fifth one, you have to add another interval length because there's four intervals, but there's 5 points that you're dealing with. So my fifth point is right here. So it's pi over 2, and then it's 3 pi over 2. Sorry, 3 pi over 4. 3 pi over 4, yeah. Got it? So normally it starts in the middle. Here's my midline. Starts in the midline if it's a sine function, and it goes up, down, up. But because it's negative, I'm not going to start going up. I'm going to start by going down. Do you understand?
Yeah.
So here's my graph. Here's what I like to do. Plot my points in the middle. If it's a sine function, plot the first, the third, and the fifth. Plot the middle points. And then since it's a negative amplitude, it's going to go down first, and it's going to go up on that fourth point. And now just connect the dots. There's my function. There's my graph. Okay.
Okay.
Now I know that took me a long time to explain, but now I'm going to do it faster. Okay. So let's do this one. You ready?
Yeah.
I'm going to go fast through this one. So here I've got, remember, factor out the 2. I've got 2 sine of 2 x minus pi over 12. Okay. So here's my amplitude. This tells me my period equals 2 pi over 2, which is pi. And this is my phase shift, is negative pi over 12. Okay, so let's find all of our values out. So my starting point is going to be negative pi over 12. My interval lengths are going to be pi. Remember what my interval lengths are? It's the period divided by 4. So it's going to be pi is my period divided by 4. Those are my interval lengths. But the tricky part is I phase shifted it negative pi over 12. So my what did I call them before? My let's see, my interval values maybe. My interval values are going to start at negative pi over 12. This is where it gets goofy. That's my first point. You understand?
Yeah.
My second point, I'm going to add pi over 12 to that. or pi over 4 to that. And pi over 4 is the same as 3 pi over 12, right? You see what I did there? You with me?
Yeah.
So that's 2 pi over 12, which is pi over 6. So here's my first point. There's my second point. My third point, I'm going to add pi over my interval length, which is pi over 4. I'm going to add that to this next point, which is pi over 6. So that's going to be what, 2/12 plus 3/12, 5/12. Got it?
Yes.
My fourth point, my fourth interval number that I'm writing on my graph is going to be 5/12 plus another pi over 4, because that's my interval length. So that's, again, what's that? 8 pi over 12, which is 2/3. And my fifth, or my last one, is going to be 2/3 plus pi over 4. So that's what, 8 pi over 12 plus 3 pi over 12, which is 11 pi over 12. Which makes sense because look at this. Those add up to 1 pi, which is my period. From here, which is left pi over 12, to here, which is right 11 pi over 12, I'm going to get what I need. Okay. I know that seems crazy, but that's the hardest part of this. And I'm turning it into a formula for you so that it's easier for you to understand what to do. So get your phase. Let's go back and talk about what we did. Factor that out so you see what your phase shift is. And that means that's where you start. That's your starting point. That's your first point. Find your period. 2 pi over b is your period. And divide that by 4. And that tells you how to find all of your intervals, all of your interval markers. So start with the first point of your phase shift, and then keep adding your interval length each time to it. And that's where it gets, like I said, that's tricky because it's a lot of fractions that you have to deal with. But you say I have to get better at dealing with fractions, because for your class, honors pre-calc, they want you to write those interval lengths out there. Okay, so let's put those interval lengths in here now. So here's negative pi over 12. Let's call that negative pi over 12. This is, again, where it gets a little bit tricky to figure out how to put this in here, because they only give us a 5x5 graph here. So it's kind of hard to do this. And maybe not. We're going to go by pi over 12. So there's negative pi over 12. Here's 0 right here in the middle. So here's 1 pi over 12. 2, yeah, that's not going to work. Well, yeah, that'll actually work. 2 pi over 12 is pi over 6. So there's pi over 6. There's 3 pi over 12. There's 4 pi over 12 is right here. Is this making sense? Yeah. So basically every 3 of these is going to be one of my, and I just don't have enough room for this. So again, I don't like how they do this, but let me get rid of this line. I'm going to get rid of my my y-axis here. Color over it. And we're going to start further to the left. Okay. All right. So let's erase this and let's start. Okay. So we'll do it like this. This all the way over here is going to be all the way over here is going to be negative pi over 12. So then every three spaces is going to be, so there's 2 pi over, there's 0. So this is my axis right here. There's my y-axis. Okay, so that's negative pi over 12 right here. Yeah, that's 1 pi over 12. This is 2 pi over 12 right here, which is pi over 6. That's 3 pi over 12, 4 pi over 12, 5 pi over 12. That's my next one. You see how I'm doing this?
Yeah.
I know it's tedious, but like I said, that's what they do in this class. They give you these weird numbers like this. There's 6 pi over 12, 7 pi over 12. There's 8 pi over 12, which is 2 pi over 3. So this is 2 pi over 3. And then there's 9, 10, 11 pi over 12 is going to be right here. So we just need to put 2 more on here. This is 11 pi over 12. Okay. That again is the hardest part. Now I'm not shifting it up and down. So my vertical shift is 0. My phase shift, like I said, was negative pi over 12. My period, like I said, was pi. My amplitude is 2. So I'm going to go up 2 and down 2. Got it? So here is my grid, so to speak. My grid is going to be going from here, there, 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 and there. There's my 5 points, my 4 intervals and my 5 points. And my top line is here. My midline is that the x-axis, and my bottom line is here. Got it? So now I'm going to put my points on here. Remember, what does a sine graph do? Starts in the middle or on the top or the bottom? What does the sine graph do? It starts in the middle. Okay. See how my sine graph started in the middle? Now, why did this one go down? I can't hear you if you're talking. Why did this graph go down?
This graph goes down because it's a negative. Yeah.
That's right, because the amplitude was negative. So this is starting in the middle and it's going where?
This one's going to go up.
Very good. So my graph is going to be starting in the middle, midpoint in the middle, end point in the middle, and it's going up to start and it's going down at that 4th point. So there's my graph. Now it said graph 2. It said graph 2 periods. So I guess you can just do another, you'll just have to do another period. Again, they gave you a small piece of graph paper. So if you wanted a graph 2, you just have to do that one more time. Just keep going one more time. Down, midline, up, finish. Right? There's your 2 periods. For this one, it's going to be harder because I spread it out so it was easier to see. But basically, you could do 2 more if they're asking you to do more. Just keep going, 2 more. Okay, but those are your points. The domain, sorry, I didn't do the domain and range. Can you see the domain and range? The domain is basically all real numbers. And the range goes from -2 to 2 inclusive. For this one, the domain is all real numbers. And the range goes from -1 to 5. You see that?
Yes.
Good. Understand how we did that? Is that pretty clear?
Yeah.
All right. Again, trickiest part, like I'm saying, It's the interval, finding those interval points and doing all that junk. All right, let's try this one. Oh, by the way, a cosine graph, if this had said cosine instead of sine, what's the only difference?
Would it go down first and then up?
That's right. It would have started here and ended here, and the midpoint would be at the bottom. So it'd be doing this. It's just shifted basically. Okay. So now we're doing cosine. It's the same deal. We're going to take our, here is our period. This is B. So the period equals 2 pi over that. Flip and multiply. The pi's cancel. And you get 8 over 3. So your period is 8 over 3. Again, they like to do this for your honors pre-calculus. They give you these really goofy numbers. So you have to deal with fractions, whatever. There's your period. Okay. Notice there's no pi's in this. So that's your period. Your phase shift is -1/2. It's your C, right? It's this number here. Your vertical shift is -3. So you're going to start at -3. You're going to go down here. You're going to start at -3. Your amplitude is 1/2. Okay, thank you very much. So that means you're only going up 1/2 from that -3. So your top your top point is right here. You see how stupid this is? So we're going to fool them. And we're going to call this what they drew in as your y-axis. Instead of y equals 0, we're going to call it y equals -3. And we're going to go, and we're going to call this right here, we're going to call this line y equals -2. In other words, we zoomed in on it, and this is y equals -2.5. You understand what I did? I just zoomed in and gave us a little bit more room. So this is my top line, and this is my bottom line. This is y equals -3.5. Okay, just to give us a little bit more room to work. All right, makes sense?
Mm-hmm.
Now let's deal with the period. It's annoying. So remember, my interval lengths are going to be the period divided by 4. So my interval lengths are 8/3 divided by 4, which is 2/3. Does that make sense?
Mm-hmm.
So each interval is 2/3, but I'm starting at my phase shift, which was -1/2. That's my first interval. So let's just draw them in. 1. There we go. So I'm going to add 2/3. I'm going to do -1/2 plus 2/3. And then I'm going to add 2/3 again, because each of these are 2/3, right? You get what I'm doing? So I'm starting at 1/2 and I'm adding 2/3. So let's get common denominators. So this is -3/6 and this is 4/6. So this is 1/6. Got it? Now I'm adding 2/3 to 1/6. 2/3 is like 4/6. So this is 5/6. Now I'm adding 2/3 to 5/6. So that's 9/6, which is the same as 3/2, right? And then I'm adding 2/3. I'm just going to leave it as 9/6. 9/6 plus 2/3, because that gives me common denominators, which is 4. 4 more is 13/6. So here are my intervals, right? Got it?
Mm-hmm.
And let's to check to make sure we did this right. We add this and this together, or we find this distance, and that total distance better be 8/3.
Yeah.
And this would be 3, 6, negative 3. 6, whoops, that's 10, 6. Nope, that's not right. So what I do wrong? That's not correct. I did something wrong somewhere. Okay, let me go back and check what I did wrong. 8 divided by 4. That is 2/3. That's correct. So each of these should be 2/3. And I'm starting at negative 1/2. So that's negative 1/2. 3, 6, 4, 6. That's 1/6. 1/6 plus 2/3. That's 4, 6. That's 5, 6. That's right. 5, 6 plus 2/3. 4, 6. That's 9, 6. That's right. 9, 6 plus. Why is this not working out for me? What am I doing wrong? 3, 6 plus 13, 6 is 10, 6. That should be the period, which is 8/3. 10, 6 is 5/3. So that's not correct. Can you see what I'm doing wrong? I must be doing some little mathematical piece wrong here. Let me go over it again. 8/3 divided by 4.
Be 2.5 or negative, oh, never mind.
8/3 divided by 4 is like 8/3 times 1/4.
8/12.
And the 4 and the 8 cancel and you get 2/3. So the interval length should be 2/3. So if I add 2/3 4 times, that's 8/3. What's 8/3 plus negative 1/2? 16, 6 minus 3. No, maybe that is right. 6. Oh, I guess it is right. What am I? So that is right. You should end up at 13, 6. Oh, I know what I'm doing. I'm subtracting these. I should be adding them together because this is on the other side of 0. That's what I did wrong. So this is the correct answer, but I should be adding them together, not subtracting them to check. The distance between here and here is going to be this minus this, which means 13, 6 plus 1/2. 13, 6 plus 1/2 is equal to 16 sixths, which is 8/3. So that checks out. My bad. I was just doing the wrong check. I was checking wrong. Anyway, so those are the right values. Okay. So what we're going to do is we're going to put them on our graph. And again, I don't like when they give us this graph paper with the y-axis on it. We shouldn't have the y-axis on because that kind of messes up what we're trying to do. So I'm going to erase the y-axis so that we don't have to deal with that. And so really we just want to find, we want basically 5 intervals on here. So let's just go like this. I'm going to do this in black. Let's start here. Let's just skip. Do it like this. There's 1 interval, 2, 3, 4, 5. There's 5 points that we're marking. And this is going to start at negative 1/2. We're not even going to put the x-axis, the y-axis in here. This is 1/6. This is 5/6. This is 3/2. And this is 13/6. So your 0 is going to be somewhere like over here. There's your y-axis somewhere over there. Whatever. We don't even need that, to be honest. Now it's a cosine graph, right? So notice what we have here. And it was shifted. See how I already shifted everything? I've already got these values over to the right. So now all I have to do is draw in, if I want to draw in my boxes like this. I like to draw that 5x3 grid, because then all I do is I take my points. It's a cosine graph and it's positive. So it's going to start on the top. It's going to end on the top. It's going to go through in the middle. It's going to bottom out. And it's going to go through the midline in the second and fourth points. Do you get what I'm doing there? So my graph looks like this. Okay. Got it? And I think you can fill out the rest of that stuff on the graph there. And I think you can probably fill this out stuff too, or this stuff out too now, right? So
Yeah.
this is your A. This is your period is 2 pi over B. So solve for, so that means that B equals 2 pi over your period as well. So if they give you your period, you plug that in here to find B. So B equals 2. You got it? Your phase shift is just your C. Oh, well, they do plus C. So never mind. So this should be, if you want to shift it right 4, we should write negative. We should write our C is negative pi over 4. Sometimes people write a plus in here. Sometimes I write a minus. And your vertical shift is your D. So my equation would be y equals 2 cosine of 2 times x minus pi over 4, because they told me my phase shift was pi over 4. So it's, I have to write the minus in there. Whoops, minus 1. There's my equation. Okay. Good. And then this is going backward from that. I'll just show you how to do this real quick. I know our time's up. To go backward from this, what you do is you reverse that whole process. So you can see that I didn't shift it. I didn't shift it up or down at all. So my vertical shift is 0. So that means D equals 0. My amplitude, you see how it goes up 4 from your midline, and it starts like that. So my amplitude is 4. So A equals 4. Got it? My period, I take this total distance basically is my period. So like I was just talking about, I do 3 pi over 4 minus a negative pi over 4. So that's just pi. So my period is pi. My phase shift for a sine graph, well, you can see my sine graph always starts in the middle. So this is my sine graph. My phase shift for my sine graph is negative pi over 4. But my phase shift for a cosine graph, well, a cosine graph is right here. It starts here, so it's actually 0. If I was doing my cosine graph, it would look like this. You understand that? So my equation for my sine graph is going to be y equals the amplitude times the sine of B is going to be 2 pi, B is going to be 2, right? Because remember, your B equals your period over 2 pi. I'm sorry, 2 pi over your period. So 2 pi over my period is just going to be 2. Got it?
Yeah.
My phase shift was negative pi over 4. So I'm going to write x plus pi over 4. Got that? And then My vertical shift was nothing, so that's it. So for my cosine graph, it's actually even easier. Y equals 4 cosine of 2x. You don't even have to put a phase shift in there. So there are my two equations.